Okay, here we go. Lesson 7, Construction Techniques 5. We're talking about squares. They ask us, this bullet point says, let's use straight edge and compass moves to construct squares. So we're going to build some circles with the compass. Use a ruler. We need a compass and a ruler for this lesson, so make sure you go and get those. Now, let's take a look at 7.1. It just says which one doesn't belong. And for this, in class, you're going to find reasons for each of the 4. There's figure A, which is looks like a square, side lengths are 2, and they shaded it in. B is a rectangle, side lengths of 3 and 1. C, you've got a rhombus, side lengths of 1. And then D, 1, 2, 3, 4, you got an octagon, side lengths of 1. So you got to figure out a reason why this one is not like the rest, why this one is not like the rest, this one, and this one. So here we go. The first one is, the first thing that jumps out to me is this is the only polygon. Polygon's it's basically it's at least 3 sides. All the sides are like sharp edges. So in other words, a circle is not a polygon, but I'll give you some examples here. Triangle, square, quadrilateral, pentagon, those are polygons, octagon. Anyways, this is the only polygon that is shaded in. That's the first thing that I noticed. Now let's go to B. B, all the other 3, all the side lengths are the same. This one has a pair of 3s and a pair of 1s, so that's the only polygon where all sides are not the same length. Something you could say for that. This C, this is the only polygon that is, looks like it's kind of like tilted. So I'm going to say it's the only one that's tilted. And let's take a look at this one. There's 1, 2, 3, 4, 5, 6, 7, 8 sides. So this is the only one that has 8 sides. All the others have 4. So only polygon with 8 sides. The rest have 4. So anyway, you just want to come up with a reason for why each of them does not belong. Okay, let's go to 7.2. So it's called It's Cool to Be Square. We've got to use a straight edge. That's a ruler. And a compass. That's going to make your circles. So to construct or build a square. Remember a square, 4 right angles. All sides same length. With segment AB, so this is going to be one of the sides of the square. So this will be one of the sides of the square. So how do you do this? Well, you need to first use a compass. So the very first thing I would do is to set your compass to A for the point and B for the pencil. Set my distance here. Okay, tighten it. Righty tighty to tighten it once you get your setting. Then you just want to put your sharp point on A. The sharp point on A. Draw your first circle. All right. Okay, so that's your very first circle that you need to draw. Now the next thing you need to do is you gotta extend this radius so that it's a full diameter. And you do that by just going through A all the way out here. So it could be there, and then you wanna mark this point here. All right, now the next thing we got to do is we got to build a circle. Center B, but the radius has to be the whole diameter, and I'll show you why. So we'll see if we can do that without having to change too much on this thing. That's pretty good. Yep. Okay. Tighten this, and then we're good. So we're gonna build. Let's just call this. We'll just go in order. So we'll call this C. So we're gonna build center B, radius BC. And I'll show you that circle here. Put that right on. Go right through C. Okay, so you got a bigger circle there. And then the next thing you gotta do, you just gotta flip it. So put the point on C now. Build that same circle, but we're gonna go look for one intersection point, which is right here. This is how you do, if you remember, a perpendicular line through a point. But we only have to go to here. And I'll tell you why. We're building a square where every side is AB in length, and this is the circle. So we know that this one, we'll just call this D. We just have to go to the outer edge of the circle. Then we know that this is going to be the same as this. And then that's a 90-degree angle. Okay, now what we need to do is build the fourth and final point. So I'm going to show you how to do that. Put your point on D. Put your compass on A. And just draw another circle. Should go right through A, and it does. That's good. Okay, now we've got this circle, center D, radius AD. Now what you need to do is extend this radius to a diameter. So we're gonna go through that point all the way to that point right there. Hey Claire? Yeah? I'm filming a video. Do you need anything?
How do you plug in the GoPro camera part?
Unplug the one that's plugging the batteries, and then plug it into. There's like a. I'll be down there in a little bit. How about that?
Okay.
Okay, thanks. So this point right here, let's just call this E up here. So now we've got this circle here, center D, radius AD, point E right there. We need to basically do the same exact thing. So we need a perpendicular line that goes through D. And we do that by setting our compass to A and E. Looks pretty close. Let me just get a read on it. I gotta go a little further. A tiny bit in. That's pretty close. Okay, now we're gonna build another circle. Here we go. Should go right. No, that wasn't very good. Here we go. Okay. Next thing is go from E, sharp point on E, pencil on A. Really just need the intersection point right there and right there. So there's an intersection point. There's one right there. So if we build this line, all we have to do is go. There's that line, but we only have to go to there. Because this is our last point that we need. Got A, B, C, D, we got E. Why don't we just call this F? So, tough problem. You now know that all four sides are the same. Shade this one in. Yeah, so your finished product should be something like this red square. But I need to see all the compass moves because that's what they asked us to do. We got to use a straight edge and a compass. So we got to do what they ask. But that's how you do it. It's a lot. So you started with AB. You got to find the perpendicular line that goes through A. And then you find the point because it's the same distance, AB. So it's always going to intersect that circle. And then you got to find also the perpendicular line that goes through D. And to do that, you first start with the circle. You extend the radius so it's a diameter. Then you build that circle, find the intersection points, draw the line only to the outer edge of the circle, radius dA. And that's how it's done. All right, 7.3. So we just have to follow the instructions basically. So here is square ABCD. So right here with diagonal BD drawn. So on this, it's pretty easy. You just got to follow the steps. So let's take a look at the first one. So construct or build a circle centered at A with radius AD. So center A, radius AD. Okay, here we go. Okay, there's the first step. Construct a circle centered at A, radius AD. Okay. Next up is construct a circle centered at C, radius CD. Well, they said this was a square, which means that that equals that. So I shouldn't have to change my compass. All I do is do another circle, the same compass setting, but centered at C. So this should still go straight through D, and it does. Okay, so that's step 2. Then the step C, or third step, is draw the diagonal. BD was an example of a diagonal. Now we got to draw AC. So that's pretty easy. There's A, there's C. Draw the line between them. Okay. And write a conjecture. Remember, conjecture. That's like a hypothesis or like an educated guess. So that's what a conjecture is. So write a conjecture about the relationship between the diagonals B, D, and A, C. Well, I'm going to say that they are perpendicular. So I'm going to say, I think, that's a good way to start a conjecture. So I think that AC is perpendicular to BD. That's what I think. And the reason I think that is because this looks awfully like the perpendicular bisector construction. Okay, so there's a conjecture, and we also did the diagonal. Now the last thing we gotta do is label the intersection of the diagonals. That's right there. So label the intersection of the diagonals as point E. So there's E. Then construct a circle centered at E, radius EB. Okay, I can do that. So there's E. Move your compass in a tiny bit. We're gonna go to EB. Okay. So we did that. Then we have to answer this question. How are the diagonals related to this circle? So how are the diagonals like A, C, and B, D, how are they related to that little circle that you just drew? This one right here. So again, how are AC and BD related to this circle that I'm doing like a dashed line? We're gonna figure out the relationship. Well, I'm going to say each endpoint of the diagonals that would be point A, point B, point C, and point D. Each endpoint of the diagonals lies on that circle. Which circle? Center, E, radius, EB. So each endpoint of the diagonals lies on that circle. These form the vertices of the square. And the diagonals are perpendicular to each other. So that's 7.3, part 1. Let's go to part 2. So use your conjecture and straight edge and compass moves to construct a square inscribed in a circle. So this is a good example. This square right here. Is a good example of a square inscribed in a circle. I still need that, Claire. So, inscribed, it's within the circle. Each of the vertices touches the circle. Okay, so this looks like it's going to be point E for us, but let's do this. So we got to construct a square inscribed in a circle. So what you need to do is pick a point. I'm just going to go in order. Let's call this A and this B. So we're going to say label A. Pick a point on the circle, label it B. 1, 2. Okay. Draw diameter from B through A and touching C. So B through A, the center, and touching C. So B through A, touching C. Okay, now the next thing you got to do is the big circles. So you got to set this to B and this to C. See if we can get there. So B all the way over to C. Okay, there we go. A little tiny bit further. Okay, here we go. Okay. Now we just switch this. Okay, now just gotta identify that point. It's the key one we need. We're gonna call that D. Now, all we need is to draw this line. It's basically from D through the center of the circle, but you just have to get this, the part inside the circle. Identify this point and this point. We got A, B, C, D. We'll call this E. We'll call this F. Now, that was the perpendicular line through A, which is going to give me the other two vertices of my square, because we learned in this one that the diagonals form a 90-degree angle, and they also form the vertices of the square. So that's exactly what we just did. All you need to do now is connect your dots. You now know that this side is the same length as this side, and this side. Just gonna shade this in for fun. Cool. So there's your finished product. Just know that we have now a square inscribed within this circle. You will notice that the diagonals of the square form a 90-degree angle. The diagonals also form the endpoints of the diagonals also form the vertices of the square. You'll need to do the perpendicular line construction, which involves a circle and two bigger circles. You jot the intersection point, connect them through the center of the circle, and that's how you build a square. All right, so we are done with 7.3. I'm going to show you the cool down. Cool down is kind of fun. It involves a lot of compass moves again. So let me get all set up here. So it's pretty much the same exact moves. They tell us to use a compass and straight edge to construct a square where BC is one of the sides. So what we're gonna have to do is first set our compass to BC. So we could also set it to CB. Looks pretty good. Okay, cool. So here we go. Center B. Make sure it goes through C. Here we go. Just gonna build our first circle. Okay. Now we know this is one side. There's gonna be another point up here. Now what we need to do is extend radius CB so that it goes through center B, connects all the way to that circle over here. So we're gonna be here, and then this is a critical point. Let's just call this D. Now what you need to do is set your compass to CD, which I know can be tricky, but it's doable, I promise. I'll show you. All we need on this is this intersection point. Make sure, yeah. So I'm just gonna go to there. Now we switch it, put the point on D. And all I need is this intersection point right there. Because that is the point we need. We'll call this point E right here. So if we just go from E to B, but instead of drawing the whole line, just go to there. Right there. Let's call that F. We know this is a perpendicular line, BF and BC. We also know that that side is the same as that side. And now we need to build a perpendicular line that goes through F. So we first need to build a circle, center F, radius BF. So center F, radius BF. Okay, now got that circle built. We now need to go from B through F, extending all the way to there. Okay, so this point, we can call this one G. I know this is a lot, but we're getting there. It's okay. Next up, we got to build two circles, one with center B, radius BG. It's going to be up here, it's going to go up here. And then we're going to switch the point and go center G, again radius BG. We are so close. So here we go. Got to extend this out pretty wide to B, G. Another way you can do it. Hey, we're in luck, a little tiny bit in. Should be right through it. Smallest little margin in. I think this is it. Could be G. Still a little tiny bit too big. Okay, that should be good. Alright, so here we go. Of course, it's going out on me right when I need it. Try that again. Of course, need to sharpen it. Work. There it is. Okay, so here's that circle. How can I do this better? Hang on. One last step, folks. I'm almost there. Might be it. Okay, now we're talking. Okay, there's that. What's this one right here? We're almost done. Need that intersection point right there. This through this, but only to there. is h. Makes this the same length. All four sides are the same. There is our square that we're looking for. I know this is a lot. It may seem silly even, but we have to prove why a square has certain properties, and you actually do it through compass constructions like this. So remember, we built a perpendicular line through point B. We stopped here because we had to have the same length BC, which represents every point on this circle. So we stopped there. So then you've got to build a perpendicular line through point F, which is represented by drawing this circle first, center F, radius FB. Then you find the intersection point of that circle and this circle, intersect there. And then you draw only from that intersection point to F. Why? Because we need the side to be the length of FB. So there's a circle that represents all those points. So anyway, what you're left with are perpendicular lines, meaning that this one and this one, these are also perpendicular. So that's your final drawing. This is a square. With BC as one of the sides. Tough problem. Arguably the toughest cool down yet, but we did it, and that's Unit 1, Lesson 7. This will be on your quiz. So you need to know how to construct and build things.